Welcome back to Ellensburg Amplifier Repair and Service. Back again with this Hifonics BRX1600.1D, the Brutus. We just finished up the power supply section of this amplifier board here, and we are going to move on to the output section. I have removed all the 640s in the output section. I have removed the drive card. And in the previous video you did see that we fired up the power supply, so I know that my regulated voltage is good to go here. And so what we'll do is we will rebuild the drive card here, and that's just part of one of my normal procedures on these cards, is just to rebuild them. If you're to look on the back side of this drive card from here over, it's dark. It's been really hot. So what I'm going to do is I'm going to replace these P2Ds here, and I'm going to replace the 1D transistors here, and I'm going to replace these two ICs just as a precaution for longevity of this drive card. And just as a recap, these are TL072s. As you can see, the manufacturer of this card did sand off these ICs, but as you may or may not know, Perry Babin's Guide to Amplifier Repair, this is a Type 7 drive card, or I should say a Type 7 amplifier. So a Type 7 drive card, and you will see, if you're to purchase his tutorial, you will see this particular card, which does list these two ICs as TL072s. So just as a good resource to have is Perry's Guide. He's a great guy. He's very knowledgeable in amplifiers. DIYaudio.com is where you will find him online if you need any of his assistance. I am also a member on DIY Audio. You can find me there. TWILLIAR is my username there. I don't post much there. I typically don't need to. I will post there when I'm really stumped on a board. Like on one of, I'm working on an Orion board right now that is just absolutely driving me crazy. So we will move on to rebuilding this Class D drive card. Stay tuned. I'll be right back with you. Alright, so we're back. What we're going to do is we're going to pull off the two ICs. We're going to pull off the 1D transistors here, P2Ds, and the two ICs. Those are pretty much the common things that I replace when I repair one of these amplifiers. So what I'm going to do is I'm just going to fire up my hot air gun here. And hopefully it's not too noisy. But I'm just gonna heat the card up a little bit here. And we're just gonna roll these right off the board. Just like that. Then what we're going to do is we're just going to take some of my soldering wick here, and we're going to clean up these. We're going to clean up these pads a little bit and prepare them for the new ICs and transistors. And I'm not going to use hot air to pull these 1Ds off. So I'm going to use my iron to pull those off. Those are pretty small. It doesn't take a lot of heat to get those off. So we're just going to clean up the pads on this. I'll try to make this process just as short as possible for you. And there it is. There is the card with the items removed. And what I need to do is also remove the 1D transistors here, the two 1Ds. So I'm just going to put a little bit of flux here. That'll help remove those. I'm going to grab my solder here. What I do is I just put a little bit of solder on my tip and just heat up these P1Ds, and then they come right off the board. A little bit of flux, a little bit of leaded solder, and these come right off. So those are the two transistors. Again, if you follow or have Perry's guide, that you'll see in the schematic on these of the reason why they run so hot. So it is a good idea to just replace these while you have the card out, in my opinion. Sometimes you'll talk to someone like Perry that just does not agree with the removal of a part if it's not broken. So I'm not quite sure. I'm not quite sure how hot these have been or what kind of damage has been. I wouldn't even say damage, but just wear and tear of the junctions in the transistor. So I don't risk it. I don't chance it. I'll just replace them. I've got thousands of these, so putting two 1Ds on is not going to break my parts bin. So, and I'm just using some of my good old denatured alcohol just to do a quick clean of the flux. Again, I use this denatured alcohol. You'll see in the first video of this amplifier. It's just a quick, easy alcohol to use, and it's very fast drying, so that's why I like to use it. So there's that. There's the pads clean, the ICs removed, the P2Ds removed, the 1Ds removed. Now we're just ready to install new transistors. So again, I'll be right back with you. All right, I'm back with you again here. So I'm just gonna put some of my Amtech flux here in the locations that we're going to be putting new transistors and ICs on. The P2Ds, the two 1Ds, and the TL072s. Just a little bit of flux there. And let's go ahead and put these on here just like so. And you'll see that the 072s that they used versus the ones that I have, you'll see that they're just a little bit different in size when it comes to the solder pads. Let me just double check my 072s real quick here. So yeah, you'll see the 072s are just a little different in size. So what I'm going to do is I'm just going to put a little bit of solder on my soldering iron, and I'm just going to tack down a pin. Make sure that they're straight. And just like that. And then what I'm going to do is I'm going to take my P2Ds, 3 P2Ds here, which is your A92s. And again, put a little bit of solder on my soldering iron here. And yeah, if you guys notice, I moved my soldering iron actually I moved the camera a little closer to my other bench, which allows me to reach with the soldering iron until I can get another camera set up. Over on the other bench for where I do all my soldering. This is not where I do all my soldering. So I'm hoping the angles are coming out okay. And then I'm going to put in place 2 1D transistors. You guys ever noticed when you're doing with SMD transistors, when you lay them down on a surface, they always tend to flip on their top and not on their bottom side. So what I'm going to do is I'm just going to place these 2 1Ds right in their little home of flux there. And of course, tack those down. My tweezers have a little bit of a bend in the tip, which is making it a little hard to grab. Let me grab a different pair of tweezers here that aren't bent. There we go. And just like that, we're just going to tack everything down. Just to make sure everything's lined up where I want it to be. And now what we're going to do is we're just going to go ahead and solder everything down. So I'm just heating this up, letting the flux do its job. And once I start to see that MTAC flux bubble up a little bit, that's when I know that I've got that heat transferring through that transistor pretty decent. And this extra solder really does help transfer some of the heat away from the transistor. Just like that, we're just going to solder down the transistors here to the board. Get rid of the excess solder on the iron, because now I just need to do the legs of the 072s, and it just takes a quick touch. Just a quick touch to solder an IC down. You don't want to hang around on those pins too long with a lot of heat. Just like that. And now we're going to finish up the 1Ds here. Again, just takes just a touch of solder. Just like that. And your output drive card is rebuilt. And again, I'm just do a quick cleanup of the flux. This denatured alcohol makes quick work of flux. And there you have it, a rebuilt drive card. All right, so here we're going to reinstall the output drive card here. So I'm just going to pop the card into its spot here. It'll kind of hold itself in place just long enough for me to tack down some pins here. And I'm just going to take the soldering iron, I'm tack down the pin. Just like that. And we're just going to solder this card in place, and then what we're going to do is we're just going to fire the card up. Make sure actually I'm going to fire the board up and make sure that I have my plus minus 15 volts for the preamp section, and make sure all my regulated voltage is present for the drive card. Takes just a second to solder these pins back into place here. Make sure that I got this ground one soldered good enough here. It is a pretty substantially large ground plane here, so I may have to use the good old Hacko, but it looks like I got it. When I go to solder in the 640s, I will hit that pin with the Hacko iron, and there it is. A drive card is reinstalled. So what we're going to do is we're just going to hook up some power here. We'll get the scope fired up. We will get prepared to bring the output to life here. So stick around and we will get right to this. All right, we're back. I connected everything up off camera so I didn't have to bore anyone about hooking up scope or power or anything like that. So what I'm going to do is I'm going to go ahead and fire up the board here, make sure the power supply is good to go. And we still have a good power supply, 59.3 volts, rail voltage there for us. So what I'm going to do is I'm going to move on to our regulated voltages here, which we have 14, 7, and 15 negative. So our positive and negative 15 volts is there. And we should have, as long as we've got our power there to the drive card, we should see our negative drive. So there's your negative drive, reference to negative rail there. 71 kilohertz, and you're not going to see much of a positive drive, just because we don't have the 640s in, but you will see attempts at a drive at about the same frequency there. So it's looking for transistors here. It doesn't have any feedback on it, so what I'm seeing is some activity on the rail-to-rail drive, and again the activity on the negative drive. So in my opinion here, this does look like it's good to go. Make sure that none of my output drive transistors are heating up, and none of the power supplies are heating up. Rectifiers, good. Rectifiers, good. The 15 volt regulators are going to be a little warm. That's normal. And then so looks like we're good to go here. Good to fit in some transistors. So that's what we'll do. We verified the rail-to-rail, the low drive, the drive card. So we should be good to install the 640s. So I'll get those in and be right back with you guys. All right, we're back. So I've installed the IRF 640s in the output section here. I have a 50 hertz signal hooked up to the input of the amplifier. Gains are all the way down. All the controls are fully counterclockwise. So let's see what we got going on now. So I'm going to go ahead and fire up the board here. Make sure we're good to go here. So the relay engages, and there's our low side drive here. Let me get the oscilloscope pulled up for you guys. All right, so I got the oscilloscope set up, and let's fire this board up and see what we got going on here today. So we do have our low side drive there for you, then the relay engages, and I do have the rail-to-rail drive there as you saw on the screen, and let's see what we got for our output. So our output is present. There it is, our 50 hertz signal. With a 2 volt input signal. There's our 50 hertz signal. So this amplifier board, again, what we have done is we have rebuilt the power supply fully. The pre-drivers, we did some PCB board repair, replaced the power supply pre-drivers, replaced the power supply transistors, replaced all the gate resistors, replaced the rail capacitors with our requested kicker capacitors, rebuilt the output drive card, and installed 10 new BRX1600.1Ds in the output section. So there we have it. This board is fully up and running and functional again. So what I'm going to do is put it all back together off camera, back in the heatsink, and do some load testing on it on the on my new 8K load bench, and I will put it through the tests. I have no doubt in my mind that it's going to pass all the tests. Otherwise, we're good to go. Again, thank you for watching and tuning in to Ellensburg Amplifier Repair and Service. You can find my website, ellensburgamplifier.com, for any amplifiers that are available, and soon I will have parts listed. Thank you for all your guys' support, and please like and subscribe, and we will see you on the next video. Thank you for watching.